What did we talk about yesterday? So yesterday we did substitution. We have a 3 by 3 system. Did I make it clear to you yesterday what a 3 by 3 was versus a 2 by 2? So it's the dimensions of the matrix of the system, right? So how many variables do I have? 3, which means how many equations do I need to solve the system? 3, at least 3, right? So 3 variables and 3 equations, 3 by 3. We good? Okay. Now, is it okay that the middle equation doesn't have a y? Is it still a 3 by 3? It is, because what's really there? A 0, right? Okay. But today we're going to talk about elimination. Okay. Now, we talked about elimination the other day with 2 variables, right? So you already have that in your head, yes? So let's talk about with 3 variables. I want to start off with this equation to solve first today because of the fact that one of the variables is already missing. Okay? When one of the variables is missing, please notice that I have one equation with x and z. Think back to yesterday. If we have one equation with x and z, what do I need? Another equation with x and z. Because if I have another equation with x and z, then I can start like I did the other day in just 2 variables and 2 equations, right? Okay, so let's use this equation and this equation and eliminate y. Do you see why I would eliminate y? Why would I eliminate y? Because that's going to give me another equation with x and z, okay? That's why I'm going to eliminate y, okay? So I'm going to just rewrite this top one right here. Are you okay with that? 4x plus 2y plus 3z equals 12. I don't want to just rewrite this bottom equation right here because nothing's going to happen with that. What do I want to do with this bottom equation so that when I do write it here and combine these, my y goes away? Multiply all of this by 2. So if I multiply this whole bottom equation by 2, I get 12x minus 2y plus 8z equals negative 6. You okay with that? So now when I combine these 2 equations right here, what do I end up with? 16x. What happens here? It's 0, right? That's 0. And what happens here? 11z equals 6. Now I have this equation right here and this equation right here. And what do you notice about those 2 equations? X's are already 16, right? Is that what they need to be? No, right? They need to be opposite. That's exactly right. They need to be opposite. So how about if I take this equation and write it right down here? But before I write it right down here, I'm going to take the whole equation and multiply it by what? Negative 1. Perfect. Okay? So I get negative 16x minus 5z equals 6. Now combine these 2 equations. 16x minus 16x, so 0. 11z minus 5z, 6z equals 12. Well, if 6z equals 12, z equals 2. What do I want to do now? Oh, where do you want to plug that in? Oh, just right here? Why would we plug it in just right there? Oh my gosh, we'll already solve for another variable, right? So I'm going to take my z equals 2, and you want to plug it in this one? Is that what you said? This one, okay. Oh, the one above it? So that one? So 16x plus 11 times 2 equals 6. Well, 16x plus 22 equals 6. And if I subtract 22 from both sides, 16x equals negative 16. If I divide both sides by 16, it's nice, isn't it? So am I done? Oh, no, okay. I still have a way to go? Like a long ways? Oh, not a long ways, because I already have x and z. What do I lack? Y. How am I going to find y? Top equation, okay. Why am I choosing the top equation? Because he said. I could choose the top or the bottom. It doesn't matter because they both have a y, right? But I'm choosing the top because he said. It doesn't matter. It doesn't matter either one you want to choose. He chose the top. I don't know why. Maybe that's just what he chose. Some people would choose the top because this is positive and a small number. Some people would choose the bottom because it's already isolated. It's already like just y, except it is negative, so we'd have to divide by negative. Okay? But it doesn't matter which one you plug it into. Okay? But like I said, I'm choosing the top because he said. So I'm substituting in what I know as I rewrite the problem. Okay, so I know x is negative 1, and I know z is 2. So I plugged those both in as we're going. So negative 4 plus 2y plus 6 equals 12. And I know that negative 4 and 6 is 2. So 2 plus 2y equals 12. Subtracting 2 from both sides gives me 2y equals 10. So y equals 5. Now am I done? Still no? Okay, what do I have to do now? Oh, so I have to write it ordered triple first, right? So my ordered triple that I'm going to write looks like what? Negative 1, 5, 2. And what's the last thing I need to do? I need to check it, right? Okay, negative 4 plus 10 plus 2 times 5 is 10. 6 plus 6. So does it work in the first one? Okay. Negative 16 plus 10. Does it work in the second one? Negative 6 minus 5. Negative 11 plus 8. So is this the right answer? Without a shadow of a doubt, right? That's definitely the right answer. I'm sure of it. We good? Any questions about that? Yeah. In my opinion, are you asking my opinion? If you're asking my opinion, then the answer is yes. I think this is the easiest way to do it. If I'm given the choice between substitution and elimination, I will almost always choose elimination. And typically the time that I choose substitution is because it says solve with substitution. Okay? But you know and I know it's not the only way to do it. Okay, so write this problem down, and then we will discuss it. It's a new one. Yeah. X plus 4y minus 6z equals negative 1. 2x minus y plus 2z equals negative 7. Negative x plus 2y minus 4z equals 5. Got it? So before we start, I would like to discuss our options. Okay? We're solving this with elimination, right? Which means we have to eliminate a variable. So let's look at the x's. Do you think the x's would be a good choice to eliminate? Why do you think the x's would be a good choice to eliminate? There's already a positive and a negative. There's already like the same number, opposite sign. And the one that's not is really low. 2, right? All right? Would y be a good choice? Yes, y. So I can multiply it by 2 and then by 4, right? Eliminate it. Why else would it be a good choice? They're also relatively small, good. And they also already are some opposite signs going on, right? Okay. Would z's be a good choice? Depending on what x and y is, could it be a good choice? Yes, y. Already pretty low numbers. Opposite signs already. So in this particular problem, we have all good choices, right? In your opinion, is there a better choice? You think x is the better choice between x, y, and z to eliminate? Do you think x is the better choice? Matthew does. To be fair, I do too. Okay? I could totally do this problem for you by eliminating the y's first. But I could also totally do this problem by eliminating the z's first. But I agree with him that x's would probably be the best choice to start with. Okay? Because while the others are pretty low, this is the lowest, isn't it? Okay? So what do I need to do first? What do you want to do first to eliminate the x's? So just combine the top one and the bottom one? Are you okay with that? Because if we just direct combine the top and the bottom, what's going to happen to x? It's going to go to 0, isn't it? Okay, because they're already same number, opposite sign, right? So x and negative x is 0. 4y and 2y is 6y. Negative 6z and negative 4z, negative 10z, and then negative 1 and 5. 4. So look how much work I have shown so far, and I already have one equation with a variable eliminated. If I have one equation with y and z, what do I need? Another equation with y and z. Okay? I need another equation with y and z, which means I need to eliminate x again. But I can't use the top two. I can't use the top and the bottom. Why can I not use the top and the bottom? We just already did that, right? We don't want to do it again. We'll get exactly the same, and that's not going to help us, is it? Okay? So do I want to use the top two, or do I want to use the bottom two? Why would you choose the bottom two? I don't have to multiply by a negative because they're already opposite signs. Okay? So is it okay if I multiply this one by a 2 and just write it like right here? Are you okay with that? So if I do, I get negative 2x plus 4y minus 8z equals 10. Is that right? And then what if I take then the middle one and the bottom one? That's the ones you said to use, right? If I take the middle one and the bottom one and combine them now how they are, what do I get? Well, 2x and negative 2x is 0. Negative y and 4y is 3y. 2z and negative 8z, negative 6z. And negative 7 and 10, 3. Look at how much work I've done so far. Compared to yesterday, look at how much work I've done so far on this problem. Once I have two equations with y and z, what do I need to do now? I start over, right? I try to eliminate a variable. In your opinion, which is the best variable to try to eliminate here? Why do you think the y's are the best variable to try to eliminate? They're smaller. Exactly. They're smaller. Now, they're not opposite signs, but to be fair, neither are these, are they? Okay? So what am I going to have to multiply this equation or this equation? Doesn't matter. Which one am I going to have to? Oh, the bottom one by negative 2? So if I multiply the bottom one by negative 2, is it okay if I write it right there? Okay? So I get negative 6y plus 12z equals negative 6. Now, what if I combine these two equations right here? I'm going to combine them, and I'm going to write the answer right there. You okay with that? So 6y minus 6y, 0. Negative 10z and 12z, 2z equals negative 2. What does z equal? Negative 1. Now, guys, to be fair, is there more work that I could have written? Yes, I could have rewritten each equation each time, but I chose to use what was already written. Are you okay with that? I've been trying to draw arrows so you knew where everything was coming from. Okay? But now I know z. What do I do with it? Where would you like to plug it in? Just right here? Are you okay with that? 3y minus 6 times negative 1 equals 3. 3y plus 6 equals 3. If I subtract 6 from both sides, I get 3y equals negative 3. Y equals negative 1. And now that I know y and z, what do I lack? X. Where do you want to put it? Oh, the top one. Why the top one? X is already by itself. Could I choose the second or the third? Absolutely, but I'm choosing the top. X plus 4 times negative 1 minus 6 times negative 1 equals negative 1. Because both y and z we solved for and found were negative 1s. Okay? So x minus 4 plus 6 equals negative 1. X plus 2 equals negative 1. X equals negative 3. What's left to do? First, write the answer, right? What's the answer? Negative 3, negative 1, negative 1. And what's that called again? Ordered triple. That's my solution, right? And then what's the last thing I should do? Check. Okay, negative 3 minus 4. Negative 7 plus 6. Does that work? Okay, negative 6 plus 1. Negative 5 minus 2. Does that work? Okay, positive 3 minus 2. 1 plus 4. 5. Good? I got one more example for you today. Five x plus y minus z equals 6. X plus y plus z equals 2. 12x plus 4y equals 10. What do you notice? The z is missing. So if I already have one equation with x and y, what do I need? Another one with x and y. It means I need to eliminate these z's. Oh, look how nice that is. They're already opposite signs, right? So if I just straight combine these two together, what do I get? 6x plus 2y equals 8, because that's 0, isn't it? So now I have two equations with x and y. What should I do now? Try to eliminate a variable, right? Do you want to eliminate x or y? Y, okay. So if I'm eliminating y, what do I need to multiply this equation by? Negative 2. Why negative 2? They got to be opposite signs, right? So is it okay with you if I write it right there? So I get negative 12x minus 4y equals negative 16. What happens? That's 0. What happens? That's 0. 0 equals negative 6? Does 0 equal negative 6? Will 0 ever equal negative 6? No solution. We talked a little bit about this yesterday, right? We had the 3 pieces of paper that we talked about. These were our planes. If they were all 3 parallel, there was no solution, right? Or if 2 were parallel and went in between, there was no solution because it didn't intersect. We also talked about infinitely many solutions. We talked about how that would look algebraically. How would that look? If 0 equals negative 6 is a not true statement and that causes a no solution, what would cause an infinitely many solutions? If it was a true statement, negative 6 equals negative 6, 0 equals 0. Anything that is a true statement would be an infinitely many solutions. Okay? Any questions? Have a great day.